students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as wave motion. Now let's continue with Doppler effect that we were seeing. We'll just recap what we had done in the last lecture. We had seen what happens when the source moves towards the observer. We have already done this. I'll just recap this before I move on ahead. Will I need this again? This was source, this was observer, right? This was my wavelength of the wave, and v was the distance and the velocity, because that was the distance covered in 1 second. Now we had also shown you that as the source moves towards the observer, you would have same as the frequency remains the same, the distance between the waves is going to get reduced, so my wavelength would be reduced. Right? Let us assume that the source has covered a distance of Vs. That means now the waves would be required to cover a distance of V minus Vs. Right? Now, in that case I can say that since the source is emitting each successive wave, since the source is emitting each successive wave as it is moving towards the observer, as it is moving towards the observer, right? As it is moving towards the observer, the waves are emitted from smaller and smaller distance. Instead of waves being emitted from this large distance, they are going to be emitted from smaller distance. The waves are emitted. From a smaller and smaller distance. The waves, instead of being emitted from a larger distance, the distance between the waves is going to get reduced, right? Smaller and smaller distance from the observer. Hence, each successive wave reaches the observer in smaller and smaller time interval, because now the wave has to cover a smaller distance. So I can say that hence the successive waves reach the observer in smaller and smaller interval of time, and that is the reason why the frequency heard by the observer is greater than the true frequency. Hence, the frequency heard by the observer is greater than the true frequency. We have done this in the last lecture. I just wanted to recap this before we move ahead. Fine. And we had also said that this frequency heard by the observer is called as apparent frequency. This frequency heard by the observer is apparent frequency, and I can say that which is equal to say n bar, and then we had said that n bar is equal to V upon V minus Vs into n, where n was the original frequency. Now, as it is very clear that as V is going to be greater than V minus Vs, therefore n bar is going to be greater than n. So therefore the apparent frequency heard by the observer is going to be greater than the actual frequency, right? Thus, as the source moves towards the stationary observer, the apparent frequency heard by the observer increases. Now let us move on to another concept. If the source is moving away from the observer. The reason why I recap this is, now I will not give you the explanation. If the source is moving towards the observer, the apparent frequency is going to increase. That means if the source moves away from the observer, the apparent frequency is going to decrease, right? Source moving away from the observer. Now, if the source is moving from the stationary observer, if the source is moving away from the stationary observer, if the source is moving away from the stationary observer, then I can say, since he is moving in opposite direction, that means Vs is negative. Simple basic maths. Therefore, I can say that the apparent frequency n bar can be given as n bar. If I use the same formula, it is V upon V minus Vs, but Vs is negative here into n. Therefore, the apparent frequency will be n bar, will be V upon V plus Vs into n, right? Now, as it is very clear here from the equation that V is going to be less than V plus Vs, therefore the apparent frequency heard by the observer is going to be less than the original frequency. Fine, do we get this here? Now, so far the source was moving. Let us assume that if the observer starts moving, let us consider a case that the source is at rest and the observer is in motion. Source at rest and observer in motion. Right? Now in that case, let us assume that VO is the velocity of the observer. And let us also assume that n bar is the apparent frequency heard by the observer. Apparent frequency heard by the observer. Right? Now, if the observer is moving towards the source, if the observer is moving towards the source, then what will happen? If the observer is moving towards the source, stationary source, then the apparent frequency n bar will be equal to, now look at this guy is moving here, so in that case, in the numerator, the distance that will have to be covered is going to be V plus V0 upon V into n. The apparent frequency is going to be V plus V0 upon n if the source is stationary. I am assuming this movement to be a negative movement. So it should be the difference between the frequency, how I did here, V minus Vs. Similarly, it would have been V minus Vo. That's how I got V plus Vo in the numerator, because here the distance is decreasing. The distance in the numerator, if you are considering from one end, that is, if you are considering the source movement to be the change in the denominator, the observer movement is going to be the other way around. That's the reason I did this again, right? Otherwise, I would have had to do this, all these derivations again. So we are working on this. Now, as V plus V0 obviously will be greater than V, therefore I can say that n bar is greater than n. Right? In this case, that means the frequency heard by the observer will be greater than the original frequency. The apparent frequency heard by the observer will be greater than the original frequency. Right? Next, I can say that if the observer is moving away, from the source. If the observer is moving away from the source, then the apparent frequency will be V minus V0 upon V into N. Right? If the observer is moving away, then the apparent frequency, because I'm going to be moving in the right hand direction, right? So in that case, that's the observer is going to move in right hand direction. As I can say, as V minus V0 is less than V, therefore I can say the apparent frequency is less than the original frequency. Right? Now, let us consider the case that if the source, let us consider the case that both the source and the observer, are in motion. Right? Now let's see what would happen if both the source and the observer are in motion. Source and observer in motion. What would happen if the source and observer both are in motion? Right? Now in this case you could have different permutations. First, I could have the source and the observer approaching each other. Source and observer approaching each other. That is, the source is going to move inwards with a velocity of Vs, and the observer is going to move again inwards with a velocity of V0. Therefore, the apparent frequency, now since the observer is moving, the apparent frequency, the apparent distance that will be covered, or the distance that will be covered in the between the observer and the source, is going to be V plus V0, right? Since the source is moving towards the observer, right? In the denominator, this is going to be V minus V0. We've done this. V minus Vs, source into N. So if the source and the observer are approaching each other, then the apparent frequency will be V plus V0 upon V minus Vs into N. Next, if the source and observer move away from each other, if the source and observer move away from each other, then the apparent frequency, now the source is moving away. If the source is moving away, that means my denominator will be V plus Vs, right? The observer is moving away. If the observer is moving away, then my numerator will be V minus V0 into N. Fine, do we get this thing here? Once those basic formulas you know, then you can make these formulas. Source follows the observer. That means the source is moving with a velocity of Vs, the observer is moving with a velocity of V0. Right? Source follows the observer. In that case, the apparent frequency that will be heard, source is moving towards the observer. That means my denominator will be V minus Vs. Observer is moving away from the source, right? Moving away from the source. That means that will be V minus V0 into N. Find you with the single. Next, if the observer follows the source, observer follows the source. Observer follows the source. That means source is moving outwards with a velocity of Vs, and observer is going to follow them. So the apparent frequency is going to be, now since the source is moving away, from the observer, this will be nothing but V plus Vs. Since the observer is moving towards the source, therefore my numerator will be V plus V0 into N. So those are going to be the frequencies that are going to be heard when the source and the observer are moving towards and away from each other. Fine, do we get this thing here? Okay. Now, Let's start with the numericals. That finishes the theory. Let's start with the numericals. Take down the numericals, please. Take down the numerical. The equation of a progressive wave. The equation of a progressive wave. The equation of a progressive wave is represented by. The equation of a progressive wave is represented by 0.2 sine 2 pi t upon 0.08 plus minus x upon 5 where all quantities are in SI units. Calculate the wavelength and the frequency of the wave. Calculate the wavelength and the frequency of the wave. Calculate the wavelength and the frequency of the wave. Compare the above equation. If I compare this equation with y is equal to, we've done this derivation, a sine 2 pi t by t minus x by lambda. In which case if I compare this, then I'll get wavelength is going to be 5 meters, right? Time period is going to be 0.08 seconds. And what else have they asked you to find out? Wavelength and frequency. Frequency is 1 upon t, that is 1 upon 0.08. When you divide this, you will get this as 12.5 Hertz. Right? Next, take down next one, please. Write down the equation of a progressive wave. Write down the equation of a progressive wave. Write down the equation of a progressive wave whose amplitude is 0.02 meters, time period is 0.05 seconds, traveling with a velocity and time period is 0.05 seconds and traveling with a velocity of 10 meters per second. Now guys, I can say that velocity is given to me, right? So I could say that velocity we know is nothing but n lambda. Therefore I can say that lambda is v upon n. Now if I use the same equation that I used in the previous sum, I can say that equation of the progressive wave, equation of progressive wave is going to be equal to y is equal to a sine 2 pi t by t minus x by lambda, right? Now in that case I can say y is equal to a. We know the value of a as 0.02 sine 2 pi t by t, time period is given to you as 0.05 minus x by lambda. Lambda can be written as v by n. lambda can be written as V by N, right? Now this can be written as y is equal to 0.02 sine 2 pi t upon 0.05 minus x upon v. V is given to you as 10 into 1 by n. But 1 by n, 1 upon frequency is nothing but time period. So this can be written as y is equal to 0.02 sine 2 pi t upon 0.05 minus x upon 10, 1 upon n I am writing as t, which will be nothing but 0.05. Thus I could take 0.05 common. So I will get y is equal to 0.02 sine 2 pi upon 0.05 t minus x upon 10. That will be the equation of the progressive wave. Fine, do we get this thing here? Next, take the next one please. A sound note emitted from a certain source, a sound note emitted from a certain source has a velocity of 300 meters per second in air, has a velocity of 300 meters per second in air and 1050 meters per second in water. If the wavelength of the sound note in air is 1.5 meter, find the wavelength in water. Find the wavelength in water. Now we know that when a sound wave moves from one medium to another medium, the frequency remains unchanged. So as sound moves from one medium to another, its frequency remains unchanged. Therefore, I can say that frequency is going to be equal to, now V is equal to n lambda, so n is going to be V upon lambda. So I can say VA upon lambda A, which will also be VW upon lambda W. Frequency in air will be the same as frequency in water, right? Therefore, I can say that VA upon lambda A is VW upon lambda W. You have all the values, you should be able to get the answer. The answer for the sum should be 5.25 meters. Next, take our next one please. A sound wave of amplitude 10 centimeters, a sound wave of amplitude 10 centimeters and frequency 1000 hertz is traveling with a velocity of 331 meters per second. Is traveling with a velocity of 331 meters per second. Calculate the displacement of the particle. Calculate the displacement of a particle at a distance of at a distance of 3 meters from the origin, at a distance of 3 meters from the origin after 1.001 seconds. After 1.001 second. Straightforward, everything is given to me. I can use the formula, simple harmonic progressive wave formula, y is equal to a sine. This can be written as 2 pi n t minus x upon b. This was the same formula I used in that second sum. Right? I modified and used the same formula. All the values are given to you. You have to just straight substitute the values. The answer for this sum should be y is equal to 0. Next, take on next sum, please. The equation of a simple harmonic progressive wave. The equation of a simple harmonic progressive wave is given by. The equation of a simple harmonic progressive wave is given by y is equal to 4 sine pi t upon 0.02 minus x upon 75. Find the displacement and the velocity of the particle. Find the displacement and velocity of the particle at a distance of. Find the displacement and the velocity of the particle at a distance of 50 centimeters from the origin at an instant of 0.1 second. At an instant of 0.1 second. Right? Now first of all, let's simplify this equation. Y is equal to 4 sine. Instead of pi, I will make it as 2 pi. That means I have multiplied by 2. If I multiply the numerator by 2 to keep the equation constant, I should multiply the denominator also by 2. So whether I write pi into t minus t upon 0.02 minus x upon 75, or I write 2 pi upon t upon 0.04 minus x upon 150, it is the same thing. Now compare this equation. Y is equal to a sine 2 pi t by t minus x by lambda. So in that case, I can therefore say that t is 0.04, lambda is 150, this is seconds, this is centimeters, because all units are given to you in SI units. What else can I find out? I can find out A. Amplitude is going to be 4 centimeters. Right? What are they? Yes.
So if we multiply over 2 pi, 2 pi doesn't make a difference.
I multiply the numerator by 2 so that I can compare with the general form. I'm multiplying the angle, I'm not multiplying the number. This whole thing is an angle, huh? Right?
Yeah.
Now, once I have this, I can say that omega is nothing but 2 pi upon t, right? So that is going to be, I know t, I can find out omega. What else have they asked me to find out? They have asked me to find out the displacement and the velocity. Displacement we've already found out. Displacement is, substitute the values. They've given you the value of x and t, substitute it in the equation only. I can say y is equal to 4 sine 2 pi t, that is 0.1 upon t, 0.04 minus x 50 upon 150. Simplify this equation, that will give you the displacement. Second part of the question, they've asked you to find out the velocity. Velocity is nothing but from SHM, omega square root of a square minus y square, because here the displacement is along y axis. In that in SHM we had done omega square root of a square minus x square, because my displacement was along x axis. Here the displacement is along y axis, therefore I am writing this as a square minus y square. Y you would have found out from here, omega you have already found out right in the beginning, you should be able to get the velocity. The answer for the sum should be, displacement should be 3.464 meters centimeters, and velocity should be equal to 314.2 centimeters per second. Right? Take our next one, please. A simple harmonic wave has an amplitude of 5 centimeters, and a frequency of 5 hertz, is traveling in positive x direction, with a velocity of 40 meters per second, calculate the displacement at 30 centimeters. Calculate the displacement at 30 meters, not centimeters, sorry, 30 meters, and time period 1 second. Time is 1 second. Right? Now we know that V is equal to n lambda. Hence I can find out the value of lambda. I can say lambda is nothing but V by n. I know V, I know n, I should be able to get lambda. Once I have this, then I can say that I can use the equation y is equal to a sine 2 pi nt minus x by lambda. Lambda I know, n I know, time interval is given to me, I should be able to get the displacement. Straightforward. Right? All the values are given to me. The answer for this should be, answer y is equal to 5 centimeters. Next, take on next one please. A sound wave of amplitude 10 centimeters, a sound wave of amplitude 10 centimeters is traveling with a frequency of 1000 hertz, and a velocity of 310 meters per second, Calculate the displacement of the particle. at a distance of 3.1 meters from the origin. Calculate the displacement of the particle at a distance of 3.1 meters from the origin after 1.004 seconds. Also find the phase difference. Also find the phase difference between. Also find the phase difference between. First part of the question: two particles in the path of the wave. Two particles in the path of the wave separated by 0.0775 meters. And second part of the question: two positions of a particle. Two positions of a particle. Two positions of a particle after a time interval. Two positions of a particle after a time interval of 0.001 second. Now first of all, everything is given to you, so I could find out the displacement by using my simple harmonic motion equation. Y is equal to A sine 2 pi n. If I take n outside, this will be t minus x by v, and this is the same formula I used in the second sum. So 2 pi n, because frequency is given to me, I can use this formula 2 pi n t minus x by v. So I'll come to know my displacement. Next, now that phase difference, they've given you that path difference. Path difference delta x is given to you as 0.0775 meters. They've asked you to find out phase difference. For that, first I need to know the wavelength. Now we know that v is equal to n lambda. Therefore lambda I can find out as v by n. I know v, I know n. So I'll come to know lambda. Phase difference is given by the formula. Phase difference is given by the formula 2 pi upon lambda into delta x. Lambda I know, delta x I know, I should be able to find out my phase difference. Next, they've also asked you to find out the phase difference when time difference is given to you. There you found out the phase difference when path difference was given to you. Now, time difference is given to you as delta t, which is 0.001 second, right? They've asked you to find out phase difference. In that case, phase difference is given by the formula 2 pi n delta t. So when path difference is given to you, the formula is 2 pi by lambda delta x. When time difference is given to you, it is 2 pi n delta t. Fine, do we get this thing here? Next, take on next one please. Write down the equation of a wave. Write down the equation of a wave having an amplitude. Write down the equation of a wave having an amplitude of 5 into 10 raised to minus 2 meters. Wavelength 3 into 10 raised to minus 2 meters. Velocity 50 meters per second. Traveling along positive direction x-axis. Traveling along positive direction x-axis. Now guys, V and lambda is given to you. So I can find out N. V is equal to N lambda. So I'll get N is equal to V upon lambda. Right? Once I have N, I can use my equation of simple harmonic wave, harmonic progressive wave. Y is equal to A sine 2 pi nt minus x by lambda. Let's see, do I have all the parameters with me? N I know, T I have to get the equation in terms of progressive wave. N I know, lambda I know, x and t. So you get your equation in terms of x and t, right? The answer for this sum. Okay, I didn't get the answer for the previous sum also. The answer for this sum should be y is equal to 5 into 10 raised to minus 2 sine 2 pi upon 3 into 10 raised to minus 3 50t minus x. I take down the answer for the previous sum also. For the previous sum, the answer is going to be displacement answer is going to be 0. Path difference answer is going to be pi by 2 radians. Sorry, phase difference is pi by 2 radians, and phase difference in the case of time difference is 2 pi radian. Answer 2 pi radian. Right. Let's move on with the next sum, guys. The equation, write the equation of a progressive wave. Write the equation of a progressive wave having frequency of 256 Hz. Write the equation of a progressive wave having frequency of 256 Hz. Wavelength of 6 meters. Wavelength of 6 meters and amplitude of 1 centimeter. And amplitude of 1 centimeter. Replica of the previous sum, y is equal to a sine 2 pi nt minus x by lambda. N lambda a, all three you have, you can get the equation. Simple, straightforward substitution it is, right? You should get this answer as y is equal to 0.01 sine 2 pi 250/60 minus x by 6 meters. Next, take on next one, please. The equation of a progressive wave. The equation of a progressive wave is. The equation of a progressive wave is y is equal to sine pi 4t by 0.05 minus x by 0.5. Find the amplitude. Find the amplitude, frequency, wavelength and velocity. Find the amplitude, frequency, wavelength and velocity. Now, first of all, let's rearrange the equation. I can say that y is equal to, A can be written as 1 sine, take 2 common outside, so you will get 2 pi. So in that case this will become 2t. 2t can be written as t upon 0.05 upon 2 minus x upon, I have multiplied the numerator by 2, that means I need to multiply the denominator by 2, right? So in that case I will get y is equal to 1 sine 2 pi t upon 0.025 minus x upon 1, right? Once I have this equation ready, then I can say that compare with y is equal to a sine 2 pi t by t upon x by lambda minus x by lambda. So in that case, if I compare, I'll get amplitude is 1 meter because everything in SI units. Time period is 0.025, and what else is given to me? Lambda is 1 meter. Okay, now they've asked me to find out find the amplitude. We already found out. Frequency is 1 upon t. Wavelength we've already found out, right? And velocity v is equal to n lambda. I know n, I know lambda, I should be able to get that, right? The answer for this sum should be amplitude, so we've already found out. Time period I found out. Frequency should be 40 hertz, and wavelength I've already found out. Velocity should be 40 meters per second. Next, take on next one please. The equation of a progressive wave is given by y is equal to sine pi 20t minus 4x. First let's rearrange the equation. I can say y is equal to 1 sine 2 pi. I am taking 2 common outside, so this will become 10t minus 2x, right? Now this can be written as y is equal to 1 sine 2 pi. Numerator can be written as denominator. So this is t upon 1 upon 10 minus x upon 1 upon 2. Numerator can be written as denominator of denominator. Now I can say compare with y is equal to a sine 2 pi t by t minus x by lambda. So in which case I'll get a is 1, t is 1 upon 10, and lambda is 1 upon 2. What have they asked me to find out? They've asked me to find out, just complete the question guys. Find the amplitude, frequency, wavelength and velocity. Find the amplitude, frequency, wavelength and velocity. Right? Now we already know the time period, so we can find out the frequency. Frequency is nothing but 1 upon t. I should be able to get that. And velocity, v is equal to n lambda. N I know from here, lambda I know from here. I should be able to calculate and get that answer. Next, take on next one please. the frequency of vibration of a tuning fork, the frequency of vibration of tuning fork, the frequency of vibration of tuning fork is 512 Hertz. And velocity of sound in air is 320 meters per second. What is the distance covered by the wave? What is the distance covered by the wave in 60 vibrations? What is the distance covered by the wave in 60 vibrations? Very simple, very straightforward. I can say that V is equal to n lambda, right? I know V, I know n, I should be able to get lambda. But what is lambda? Suppose if I get the value of lambda as 0.625 meters. Now what is lambda? Lambda is the distance covered in one vibration. So I can say that distance covered in one vibration is 0.625 meters. Therefore, what will be the distance covered in 60 vibrations? Distance covered in 60 vibrations will be 60 into 0.625 meters. Multiply and you will get your answer. Next, take down next one please. Two sound waves have wavelengths. Two sound waves have wavelengths 85 upon 170 meters and 85 upon 172 meters in air. Each wave produces 4 beats per second. Each wave produces 4 beats per second with a third note of fixed frequency. Each wave produces 4 beats per second with a third note of fixed frequency. Find the frequency of the third note. Find the frequency of the third note and the velocity of sound in air. Find the frequency of the third note and the velocity of sound in air. Now guys, I'm dividing by 170 here, I'm dividing by 172 here. So it is very obvious that lambda 1 is going to be greater than lambda 2. Right? Okay. We also know now we know that guys, V is equal to n lambda. That means n and lambda are inversely proportional to each other. That means I can therefore say that n1 is going to be less than n2. Right? Now I can say n1 is nothing but V, velocity of sound in air, is constant upon lambda 1. N2 is going to be V upon lambda 2. What is beats? Beats is nothing but the difference between the frequency. Let N be the third note, frequency of the third note. Right? Let N be the frequency of the third note. Beats are nothing but larger frequency minus smaller frequency. Now between N1 and N2 we had already said that N2 is the larger frequency. So N2 minus N is going to be 4. Therefore I can say that N2 is N plus 4. Larger frequency minus smaller frequency. N1 is the smallest frequency. So N minus N1 will be equal to 4. Therefore, n minus 4 will be equal to n1, right? Now I can say that, therefore, if I divide the two equations, I can say n1 upon n2 is going to be equal to n1 can be written as n minus 4, n2 can be written as n plus 4. But n1 we had found out as v upon lambda 1. So I can say v upon lambda 1 upon v upon lambda 2 is nothing but n minus 4 upon n plus 4. V and V will get cancelled. So in which case I will get lambda 2 upon lambda 1 is equal to n minus 4 upon n plus 4. The only unknown in that equation now becomes n, so you will come to know the frequency of the third node. Once I know the frequency of the third node, and I have the frequency of third node, I can say that from here I will come to know the value of n. I can also say that V is nothing but n1 lambda 1. n1 I know, n1 lambda 1. So in that case n1 we said is nothing but n minus 4. So n minus 4 into lambda 1, and I would have already found out from there. Lambda 1 is given to me in the sum, so I'll come to know the velocity of sound in air. The answer for the sum should be answer third node n. Frequency of the third node is 684 Hertz and velocity of sound in air is 340 meters per second. Next, take on next one please. Wavelength of two sound waves in air. Wavelength of two sound waves in air are 82 upon 173 meters and 82 upon 171 meters. They produce 9 beats per second. They produce 9 beats per second. Calculate the velocity of sound in air. Calculate the velocity of sound in air. Guys, see this. Here I am dividing by 173, here I am dividing by 171. That means obviously lambda 1 is going to be less than lambda 2. Therefore, n1 is going to be greater than n2. Right, there is no third frequency here. That means beats are produced between these two frequency only. Beat is nothing but larger frequency minus smaller frequency. Therefore, I can say that n1 minus n2 is 6. N is nothing but V upon lambda. So V upon lambda 1 minus V upon lambda 2 is 6. V common. 1 upon lambda 1 minus 1 upon lambda 2 is 6. You know the value of lambda 1, lambda 2. You should be able to get the value of V. Answer should be, answer V is 369 meters per second. Next, take on next one please. Two sound waves of 81 centimeters, two sound waves of wavelength 81 centimeters and 82.5 centimeters produce 8 beats per second. Produce 8 beats per second. Determine velocity of sound in air. Determine velocity of sound in air. Replica of the previous sum, guys. Let's see this. Now, I can say that from the figures it's very clear that lambda 1 is less than lambda 2. Therefore, n1 will be greater than n2. There is no third frequency. That means beats are larger frequency minus smaller frequency. That means N1 minus N2 will give you the beat. How many beats are produced? 8 beats are produced. Right? N1 minus N2. N is nothing but V upon lambda 1 minus V upon lambda 2 should give you 8. Right? The answer for the sum should be, answer is going to be 356.4 meters per second. Next, take down next one please. Two tuning forks have frequencies 320 hertz and 340 hertz. Two tuning forks have frequencies 320 hertz and 340 hertz and produce 6 beats per second. And produce sound waves, just make that correction guys, and produce sound waves of wavelength differing by 6 centimeters. And produce sound waves of wavelength differing by 6 centimeters. Find the velocity of sound in air. Now guys, N1 is less than N2, therefore lambda 1 will be greater than lambda 2. Lambda 1 minus lambda 2, that's the difference, is 6 into 10 raised to minus 2 meters. Right? Now we know that V is equal to N lambda, that means lambda is going to be nothing but V upon N1 minus V upon N2 is 6 into 10 raised to minus 2 meters. N1 and N2 I know, V is the only unknown, I should get the answer for this. The answer for this sum should be 326.4 meters per second. Right? Take on next sum please. A tuning fork C produces 8 beats per second. A tuning fork C produces 8 beats per second with another fork D of frequency 340 hertz. A tuning fork C produces 8 beats per second with another tuning fork D of frequency 340 hertz. When the prongs of C are filed a little, the beats per second decreases to 4. Find the frequency of C before filing. Now let's assume that frequency of fork C is say X hertz. Frequency of fork D is given to you as 340 hertz. Now before filing, C and D produce 8 beats per second. We will represent this as B. B is 8. Now beats is nothing but larger frequency minus smaller frequency. we don't know which is the larger frequency, which is the smallest frequency. That means either x is going to be n plus minus 8, either it is going to be more or it is going to be less. So either I can say that x is going to be n, 340 plus 8, that is 348 Hertz, or x is going to be 340 minus 8, that is 332 Hertz. These are the two possible frequencies that tuning fork C can have. Now, when the prongs of C are filed, they've given you that its frequency should increase. If the prongs of C are filed, its frequency should increase. Right? Now let's assume that if x is 348 Hertz, let's consider the first case. That means after filing, the frequency of x should become more than 348 Hertz. Then, if x is for filing, then after filing, x should become greater than 348 Hertz. If x becomes greater than 348 Hertz, the frequency of D remaining constant, then the number of beats per second would increase, right? And therefore B should become greater than 8, but B is equal to 4, therefore x cannot be equal to 348 Hertz, right? If x is say 332 Hertz before filing, right? Then after filing, x will become greater than 332 Hertz. 332 Hertz, right? That means it will come that much more closer to the frequency of D, right? In that case, B should be less than 8. Here B is less than 8. The number of beats obtained after filing are less than 8, right? But B is 4, which is less than 8. Therefore, x is going to be 332 Hertz. Therefore, the frequency of tuning fork C before filing is going to be 332 Hertz. Fine, do we get this thing here? Okay, we'll stop this here for the day. Thank you very much.